Howdy! Today we will be going through soldering techniques, specifically in reference to the KRISYS sensor board that goes along with the KRISYS robot. We will be going through some surface mount techniques as well as some through-hole techniques that will be used for this board. We will be going along with the instruction manual that was included when you ordered the kit.
Before you get started soldering, make sure you have several of these components laid out. You have a good soldering mat because you don't want to burn a hole through your workbench. Have a soldering iron with a medium tip, some lead-based solder. We like to use a lead tin-based solder with a flux core. Make sure you have a scrub pad to clean off your soldering iron, a pair of diagonal cutters to snip wires off, a pair of tweezers for your surface mount parts, and in case you make mistakes, a flux pen and soldering braid.
Okay, so we're going to start with the resistors. There should only be one pack of 1 kilo ohm surface mount resistors. They're shown in the instructions. They're boxed in red on where exactly to be soldering them. We're going to first start with R1, which is right here. And the first thing you're going to want to do is have your soldering iron preheated. Make sure that you have tinned the tip adequately. And just kind of smooth it out. So the first thing we're going to do is we're going to tin one of these pads here on R1. Either one, doesn't matter, whichever one you want to start with. Start by heating the pad for a moment and then applying solder to it. And you should get a little bubble of solder. Take some tweezers and grab one of the resistors and just kind of hold it next to the pad. Take your other hand with the soldering iron and heat the pad to remelt the solder and set the resistor on top and kind of just hold it in position. And we will adjust this position as we go. Be sure not to heat the pad for too long because you risk damaging your board. And we want to have a good solid connection. We want to make sure you don't get any cold solder joints. So we're going to move to the other side of the pad and heat it for just a moment and apply solder to nicely cover both sides of the resistor. Make sure both are covered. It may not end up being the prettiest thing in the world, but a good connection is a good connection. Worth noting also is that the resistors have no polarity. You can put them in either direction on the pad. It does not matter. In fact, the numbers are 1001, so you can't tell one side from the other anyway. So as you can see in the instruction manual, now that we've finished the resistors, we've now moved on to the green LEDs. But first, before we get started on those, you have to note that LEDs are polar, which means you have to solder them in the correct direction. Now, fortunately, we've provided a little LED symbol for you on the board right here and on all the other LED positions. This symbol shows you which direction to put the LED. Now you see that part of this symbol is a little triangle. Now imagine it's an arrow pointing, in this case, in this direction. Okay? There is also, on the LED itself, which is right here, this is currently upside down. On the LED, there is a line down the middle, a little green line, and to the side, to one of the sides of that line, there's a little green dot. That dot is going to go in the same direction that the arrow points. So the way I have it right now, where the dot's on this side of the green line and the arrow on the symbol is pointing to this side, is correct. So be sure to solder it in this orientation. Now you will have to flip it upside down, so pay attention to the direction you have it in, but this is something you have to take note of. Your LED will not work if you solder it in the incorrect direction. Other than the direction, this will be soldered in essentially exactly the same way as the resistors were. You're just going to pay more attention to the direction. So again, firstly, we're just going to pick a pad and put a little solder on it. Remember not to heat it for too long. And be sure to clean your tip off. So now we're going to carefully grab the LED. I would grab it with the tweezers horizontal like this. Grab it very carefully and carefully spin it over and place it in place, and don't mess with it again. So now we're just going to do it exactly like the resistor, since we know it's in the correct direction. Just slide it into place. And we can always come back if it's not quite in the right spot and adjust it. But as long as there's solder on it, it will function correctly. Then we apply solder to the other pad. And it looks to me like this pad needs a little bit more, so I'm going to add a little bit more just so that it covers the pad. Something else you can do is to take your tweezers and press them gently, but with some force, on top of the LED, and heat each side separately. And just give it a little bit of downward pressure just to make sure it's seated on the pad just like you want it. And now that we've finished the green LEDs, we're just going to move on to do essentially the same thing, but with the red LEDs. Now, remember, you included with your kit were 3 red LEDs and 4 green LEDs. So be sure you're using the pack of 3. To reiterate again, LEDs are polar, so be sure to follow the exact same technique as we learned with the green LEDs to solder these on. It's exactly the same. And remember, if you're confused on where anything goes, just be sure you're constantly referring to the instruction manual provided to you.
So now after the hard part, you have to start with through-hole soldering. We start out using the 1 kilo ohm resistors, and as previously noted, their color code are brown, black, red. These go in these locations. First, take your resistor and bend it so that you have a simple U shape. Place that through your sensor board at the corresponding locations. Place it through your sensor board. Repeat this process for all 3 of your 1 kilo ohm resistors. Once your sensor board has your 1 kilo ohm resistors through them, make sure they're flush and then bend the leads on the far side so they stay in place. Once you've done this, flip over your sensor board. Re-tin your tip and clean off the excess solder. Now, when you solder on these through-hole holes, make sure you put your soldering iron down, your solder, remove your solder, then your iron. Otherwise, you will have your solder wire stuck to your sensor board. Iron, solder, solder, iron. Repeat this process for all of the leads. Once you've soldered all of your through-hole wires, take a pair of wire snippers and cut off the excess. Be careful not to do this while the wire is pointed at anyone, or otherwise it can fly off at them. Safety first. Now that these are snipped, turn your board back over and continue with the 27 kilo ohm resistors. They are color coded red, purple, orange. These resistors go here, here, and here. And solder these exactly the same way you did with the 1K resistors. Now to do the 10 kilo resistors. They are color coded: brown, black, orange. Also note that your resistors are not polar, so they can be soldered in any direction. They will go on every other remaining resistor mount here on the sensor board. Now we're going to go back to soldering diodes. These diodes go in D1, D4, and D7. These are through-hole diodes, and again, they are polar. So when you look at your diode, you see a silver strip on one end. This little silver strip corresponds to the side on the silkscreen. Put your diode through, bend the leads, turn it over, and solder. Once you get the diodes through the hole, before you solder, make sure you check that the silver line is next to the white line on your silk screen.
Now we're going to move on to these ceramic capacitors. You can see it right there. Right there. These are going to be much like the resistors were with soldering them, in that they are not polar. You can put them in any direction. So let's go ahead and slide one of these guys into the areas marked with C. It's going to be the same capacitor for all three, or the same type of capacitor rather, for all three spots marked with a C. So again, just like the resistor, you're going to want to bend it out a little bit and make sure it stays in place. And then we are just going to solder it in place in exactly the same way. Okay, now we're going to do the other two. The next thing in the instruction manual is op amps. Now op amps have 8 pins each, and they go in these little areas labeled with U's. This one's U2, U1, and over here out of shot is U3. Now you'll notice on each of these little areas they have a white dot next to the name label. This is going to correspond with, there is a dot you can see right here on the op amp. Notice that it also has a little half circle divot. If I can, well, it went into place. There's a half circle divot right here at the top. And you can see the dot and you can see the half circle. Now you can notice that these little outlines also have the half circle and they also have the dot. Make sure that the op amp, the little half circle and dot, line up with the half circle and dot on the image. These parts are the most expensive of all the components here, so make sure they're in correctly. Otherwise you will have to desolder them, and that is not a fun process because there's 8 pins. This is something you can do with these components, these 2 lead components. It is very difficult to do with the 8-pin op amp. So soldering these will be a little different because we still want to solder from the bottom of the board, but if we flip this over right now, this thing's just going to fall out. So what we're going to do is we're going to just pick one of the corner pins. This one's closest for me, so I'm going to choose this one. And we're going to just put a little dab of solder on it, just to hold it in place, and then we're going to flip the whole board over and solder all 8 pins. So the pin I chose to do a little tack solder on to hold it in place is this one here. So it doesn't really matter where you start with, maybe the opposite corner, but don't start with this one because it'll reheat this pin and the op amp will fall through and then you'll just have to start all over. So maybe since I did this one first, maybe start with the far corner and work my way in towards that. You can do it however you want, but just don't start with the same one you tacked on with. Next on the instruction manual is instructions on the potentiometers, which are right here. These go in these slots labeled R5, R13, and R21. Now it's a little hard to screw these up. They are in a triangular pattern. They have 3 leads on the bottom. Let's see if I can show you that. So they have 3 leads, and you'll notice that there are the 3 holes to receive them. So the 2 in the back go with the 2 that are next to each other. And what's even better about these is when you push them in, they will kind of click into place. So they're already in there pretty good. So we won't have to do any tack solders or anything. We'll be able to flip these over pretty easy and solder them from the bottom. So I'm going to go ahead and do that now. Okay, and there you go. There's a completed potentiometer, and now we'll do the other 2 in exactly the same way. Okay, next on the instruction manual, we are going to do the MOSFET transistor. It's going to go in the slot Q1 right here in what is to you the upper right-hand corner of the board. Now, you'll notice that there's a little, well, the diagram for this is sort of a half circle, maybe a little more than half, but approximately a half circle. Now, the component itself, if you can see that, is a half circle. So just like a lot of other things, we're basically just going to line this up with the image on the board such that the flat side is lined up with the flat side of the semicircular image. So we're going to stick it in there just like that so that it sits up a little bit, and then again, as with everything else, we're going to flip it over the back to solder it there. But again, make sure that the flat side is lined up, or rather on the same side as the flat side of the semicircular pattern on the silkscreen. Next, we're going to just cut the leads off, just like with everything else. And again, make sure to be careful about where they go. You might hold your finger on top of it to control its movement. And with that, we have a soldered transistor.
Now we have 2 components left. We have our 6-pin header and our inductors. The next one we're going to do is our 6-pin headers. They go over here at P7. This is where your signals from your sensor board will be transmitted to your intelligence. Place the short end of your 6-pin header into the holes on the sensor board where you're looking down at the silkscreen. As such. Flip the board over and then solder the pins. Make sure these have good solder joints, as if these are not connected, no signal will transfer between boards. And be careful when you flip this over, as the pins will be hot on the other side. And there are your 6-pin headers. Next, you're going to solder your 104 inductors. You have 3 of these, and before you solder them, you need to make sure that their nominal impedance is between 230 to 250 ohms. If it is a little bit higher or lower, that is okay, but if you read anything like kilo ohms or mega ohms, you have a broken inductor, and you need to get another one. What also makes these special is they're soldered on the bottom of the board, so you need to flip your board over and get those through there. Now you're going to solder your inductors. They will go on the bottom side of your sensor board in L1, L2, and L3. These elements do not have polarity. Be very careful when bending the leads to go into the holes to solder. If these break, you will lose the functionality of the inductor. Just flip it over. If you have any question on where they are, just look for the sets of 2. Get your inductor in there with about a 1/4 to 1/2 inch of room between the cap of the inductor to the surface of the sensor board. Flip the board over and solder this time on the top of the sensor board. Repeat this for all other inductors. Last but not least, after everything is soldered, you need to bend your inductors over so that you can actually read your sensor values. Your inductors are your sensors, so be very careful with them. Ideally, these inductors will be flush with the sensor board, or if not, a little bit further out, but they would be perpendicular to the ground. After you have them bent over in place, flip your board back over and snip the leads off. Now that you've completed your KRISYS sensor board, refer to the KRISYS sensor board initial testing video to figure out how to test and debug any issues you have with your board. Thanks, and gig 'em.